The Baltic Sea Environment, Session 4, Man and the Baltic Sea, Space Bridge, Uppsala, Åbo, Turku, Gdańsk.
Welcome to the Baltic University and the fourth session of our course, the Baltic Sea Environment. Today we have connected 3 of our universities with the aid of 2 satellites, Eutelsat and Tele-X. The 3 universities are Uppsala to the west, Åbo, Turku to the east, and Gdańsk in the south. In Uppsala, we have collected at the Biomedical Center. We are about 150 students here, and 5 of those are guests from Tartu universities in Estonia. Perhaps you should wave to your friends back in Tartu, so you see where you are. Now, I would like to know what's happening in Gdańsk. Are you there, Gdańsk?
Yep.
How are you doing over there in Gdańsk?
Hello. How are you?
I see it's Jerzy Bjasiowski, who is a chemist, and he is the moderator of the Gdańsk panel. How are you doing, Jerzy?
I'm fine.
How is the weather back in southern Baltic Sea?
We have some time delay.
Here it was snow this morning. Now, do you have a few students in your room there?
Well, we have about 300 students, or even more.
Very good. I hope they have a few questions later on. First, we will hear what's going on in Åbo in Finland.
Hello, we are happily seated here. We are about 60, 70 students and quite a lot of scientists and other people.
Very nice.
Good feeling, everything okay.
What does it look in Åbo? You also have winter, as we have here.
And in this panel we do have people, we are going to introduce them quite soon here after this first connection. So we are waiting for some instructions from Uppsala now, please.
Thank you. We're going to start here in Uppsala by looking at the Biomedical Center. Actually, we have put all the flags of the 10 participating nations up on the top. And we are going to start by introducing the Biomedical Center with a short contribution. This is actually where we are, to the left in the picture here. You will soon see it from the top. There is the satellite dish that sends the signal to the satellite. And this is where it looks like from the air.
Uppsala Biomedical Center is one of the largest centers of biotechnology and biomedicine in Europe, and in fact the world. Close to 700 researchers and 700 personnel work in the complex. Uppsala University accounts for about 85% of the activity, but units from the Swedish University of Agriculture and others are also found here. The research programs range from physiology to chemistry. Gene technology is an important tool in many laboratories in the 33 departments. Virology, molecular biology, immunology, and cancer research all study the structure and regulation of genes. This is the laboratory of medical genetics and microbiology. Atomic structures of complex biomolecules, such as enzymes and even viruses, are investigated with diffraction techniques. Computerized equipment is used for data collection, and high-speed computers for the large calculations. The detailed anatomy of biomolecules explain their function and forms the basis for rational drug design. Analytical work is a key component, especially in work related to environmental issues. There are many specialized analytical laboratories. This one is equipped for automatic amino acid analysis. About 1,500 students, future physicians, pharmacists, veterinarians, biologists, chemists, and molecular biologists attend courses at the center each year. The teaching programs include several areas of importance for environmental issues. Uppsala Biomedical Center is international. Scientists from all over the world meet for symposia and seminars and to work together.
Our host here at the Biomedical Center is Lars-Olof Sundelöv, and he's director of the center. Lars-Olof.
We say that we are Very pleased to have this opportunity to greet you. Welcome to this panel session at Uppsala Biomedical Center, and which is one of the larger establishments of this sort in Northern Europe. And I think that we are looking forward to a very interesting and productive afternoon.
Thank you. I will also take this occasion to introduce our panel here. From the left, in the panel, in the picture, you will see first Jan-Erik Kihlström, who is a professor of ecotoxicology. Jan-Erik is a specialist of the influence of toxic chemicals on animals. Then we have Bertil Hägerhäll. Bertil is a project coordinator at the World Wildlife Fund in Sweden, and he has earlier worked with the similar Baltic Sea projects, both at the Swedish Association for the Protection of Nature and at Greenpeace International. So he's well acquainted with this organization. Then we come to Göran Persson, who is a undersecretary at the Ministry of the Environment and the Protection of and Natural Resources. That's the new name in English for this ministry. He was former deputy director of the Swedish Environmental Protection Agency, but after the new government in Sweden in October, he has moved over to the ministry itself. Gunnar Bengtsson here is Director General of the Swedish Radiation Protection Institute. And this institute certainly has several projects going on in the Baltic region, and he will have the chance to explain about these activities later on. Finally, we have Bengt Ove Jansson, who is a professor of marine ecology at Stockholm University. Bengt Ove is also director of the Stockholm Center for Marine Research, and you know that several of his co-workers have already contributed to this program. You are all welcome to this space bridge, and now we will leave the word to Gdansk in Poland so they can introduce themselves. Over to Jerzy Błażejowski.
Thank you. My name is Jerzy Błażejowski. I am the professor and head of chemistry department of the University of Gdańsk. Let me introduce now in a short video movie our cities and universities. Our university has about 13,000 students in 8 departments. The University of Gdańsk is spread over 3 cities, Gdańsk, Sopot and Gdynia. We can now see the chemistry department. Next is the building of the Department of Arts and Political Sciences. We also have other departments such as mathematics and physics, biology and earth sciences, law and administration, economic of production, and transport economics. In the 3-town complex, there are several other universities. One of them is a technical university, the main building of which we can see here. Other are the Medical Academy, the Merchant Navy Academy, and Naval Academy. In each of these are courses dealing with environmental problems. The city of Gdańsk reaches back over 1,000 years, and these pictures are from Gdańsk. Gdynia as a town was built in the period between last 2 wars. This is a view of the port, and this is the shipyard. Here is the holiday resort of Sopot, with its pier and a view of the western part of the Gdańsk Bay. Before us, we have Transport Economics building, in which we are sitting now. Now I would like to introduce the specialist in our panel. Starting from the left is Professor Jerzy Pacha from the Silesian Technical University, who is a specialist in influence of heavy metals on natural environment, especially in soils. Then Dr. Elżbieta Niemirycz from the Institute of Meteorology and Water Management in Gdańsk. The field of her interest is environmental protection and environmental monitoring, with emphasis on reverse pollution. Then Professor Piotr Kowalik from the Department of Hydrology of the University of Gdańsk. The field of his interest is water pollutants, environmental engineering and water management. Then Professor Marcin Pliński from the Institute of Oceanography of the University of Gdańsk. He is a specialist in marine biology, particularly algology. The areas of his special interest is Gdańsk Bay. And then Dr. Artur Magnuszewski from the Department of Geography and Regional Sciences of the University of Warsaw. The field of his interest is hydrology, teledetection, and geographical information systems. Thank you.
Thank you, Jerzy. We heard the presentations. Now it's time for Åbo to introduce themselves. Please, Erkki, it's your turn.
Hello, colleagues and friends of the Baltic University, and welcome to Turku in Finland. Dobry wieczór kolegom v Gdańsku, god eftermiddag, Uppsala. The last item we saw on the video from Turku was not a big Finnish pancake, but a top modern ice hockey and music hall, and it is in that building actually we are sitting now. Well, it's a pleasure for me to chair this panel in Finland. My name is Erkki Leppäkoski. My field is marine biology, and I'm professor in ecology and environmental protection at the Åbo Academy University here. This panel is hosted by Åbo Academy University, or in Turku, or in Åbo, if we use the Swedish name of the town. We do have two official languages in this country, and that's why we have education at all levels, from kindergarten up to highest university level. And in Turku we do have, in fact, two universities as well. The Åbo Academy University is for the Swedish-speaking minority in this country, whereas the Turku University is a Finnish-speaking one. Let's now introduce the participants of the panel. Here next to me we have Dr. Terttu Melvasalo. Where do you come, Terttu, please?
Oh, I come from Helsinki Commission. I'm working in the Helsinki Commission Secretariat on environmental issues, and at the moment I'm coordinating task force of the Helsinki Commission.
And Paavo Tulkki.
Yes, I'm from Helsinki also, and working at the Finnish Institute of Marine Research as a biological field and pollution field also.
Yes, and now to next member. We know him very well already from last session. Oleg Savchuk, please.
Yes, I'm from St. Petersburg, and I'm head of laboratory in State Oceanographic Institute there, which deals with the problem of the Baltic Sea, hydrographical, physical ecosystem. And I also read lections in St. Petersburg University, Department of Oceanography.
Okay, thanks. And next one, Mikael Hildén from Helsinki as well.
Yes, I have a background with the Finnish Game and Fisheries Research Institute, mainly concerning the exploitation of the Baltic fishery resources. But presently I'm working with the National Board of Waters and the Environment with environmental impact assessments.
Thank you. You are very welcome. We also do have some other scientists here in this panel, and we are going to to introduce them afterwards. And we also have a group of students from different countries around the Baltic. We have people from Tallinn, we have people from Kaunas University, and we have some students from St. Petersburg. It is nice to see you here, students. You are welcome. And now over to Uppsala.
Thank you, Erkki. That was a really good group of people over there. And now we are going to start the discussion. And the fields of the discussion will be men and the Baltic Sea. And as a background, we will introduce to you the short history of the men's influence on the Baltic Sea. For many years, men lived in harmony with the Baltic Sea. The sea fed men with its richness of fish, let him travel widely to neighbors, gave joy and solace with refreshing baths, and not least its beauty and sound. In one generation, from about 1950 to 70, our modern society was formed. Industry grew, energy consumption increased fourfold by the burning of fossil fuels, in particular coal and oil. Agriculture, based on machines and industrial fertilizers, became an occupation for a minority, while the majority moved to the cities. Transport became the lifestyle of many. But the new society was not in harmony with its environment. The first alarms from scientists came already during the late 1950s. Heavy metals, in this case organic mercury, was found in birds. Fishing was banned in many lakes due to mercury in fish. Lead from cars accumulated in the ecosystems. The largest amounts of heavy metals were found close to industrial areas such as northern Estonia and southern Poland. In 1966, a dead white-tailed eagle in the Stockholm archipelago was the herald of the next trouble. After careful analytic work, a Swedish scientist identified a number of complex chlorinated hydrocarbons, PCBs, in the tissues of the dead bird. The eagle had accumulated the toxic chemicals in its prey until it reached deadly concentrations in its own body. Other animals were also hurt. Many of the seals of the Baltic were unable to give birth to pups. The toxic compounds came from industry, in particular the forest industry, and from agriculture, where they served as biocides. The large amounts of sulfur oxides produced by burning fossil fuels also made trouble. It turned into sulfuric acid. In 1968, the first evidence that vast land areas, forests and lakes had been harmed by acid rain were presented. The west coast of Sweden, the forests in Lithuania and southern Poland are among those which have been hurt the most. Acidifying nitrous oxides from traffic and agriculture have added to the injury. Next alarm concerned the coasts. Mass appearance of filamentous algae were signs of severe eutrophication. In the early 1980s, the dead bottoms of Kattegat confirmed these signs. Oxygen-depleted bottoms have spread over all the deeper areas in the Baltic Sea itself. The large amounts of nitrogen and phosphorus from agriculture, from sewage in the growing cities, and car traffic were the culprits. The latest blow came 1986. The accident at the Ukrainian atomic power plant at Chernobyl produced a cloud charged with the radioactive iodine and long-lived radioactive cesium. Unusual weather conditions took this to the northwest. Finland and northern Sweden were hit hardest, with the exception of Ukraine itself. Atomic power, too, had shown its black side to the environment. Concentrations of radioactive cesium are still increasing in the Swedish lakes. Today we can enumerate at least these 5 effects of modern industrialized society on our environment of the Baltic region. Nutrients, acidifying substances, toxic hydrocarbons, heavy metals and radioactivity. But what are the established scientific facts? Which activities in society are the most damaging? Which are the most urgent actions we need to take? These questions will be discussed at the first space bridge of the Baltic University. We will start by letting the Finnish students ask a question. Please, over to Finland.
Thank you, Uppsala, for a very many-sided and good introduction in the topics to be discussed this evening here in our panels at three different places around the Baltic Sea. We here in Turku have the pleasure of putting the first question. May I invite questions from students from 4, 5 different universities, please.
Hello, I'm Thomas Björkroth from Turku, and I would like to ask a question about the nutrients in the Baltic Sea. The previous program showed that the Baltic Sea receives excessive amounts of nutrients, and a part of these nutrients are of course removed from the Baltic Sea in form of fish. Now I would like to know the importance of the fisheries for the nutrients balance in the Baltic Sea.
Thank you. I guess that Finland is the one that would be most would like to answer that question the most, because I guess Finland and also Sweden, of course, has a lot of fisheries. So what about Erkki? Do you find somebody in your panel?
Yes, we really do have Mikael Hildén. I think this is your field, more or less. Please, Mikael.
Okay, thank you. This is a question that has been considered a number of times, and overall, on a yearly level, the full takeout of fish from the Baltic Sea would not take more than about 5% of the nutrients that are introduced. So on that level, it's not an option to fish out the nutrients we put in inadvertently. But that doesn't mean, of course, that the fishery do not have any effect at all on the nutrients, because studies in lakes in particular and ongoing studies in the Baltic try to find out to what extent the fishery have a structuring effect, so that the nutrient flows may become different depending on what the size and composition of the fish population and communities are. So in that way there are indirect effects, but not a direct possibility for removing all the nutrients we have.
Thank you. If you are content with that answer in Turku, I think we can go over to Gdansk and ask the Polish students to ask their first question, please.
Who would like to ask the question about peace?
I'm from Toruń. According to investigation of our hydrobiology department, Włocławek Dam reservoir accumulates during the year 300,000 tons of suspended matter, including nutrients and toxins. This accumulation is good for Baltic, but there is a problem with this bottom sediments, which have been removed and utilization. My question is, there are any investigations concerning utilization these sediments in Swedish or Finnish?
Thank you. This is, of course, a very important field. What to do with all the sedimented material in dams, in sewage treatment plants, and so on. The sludge, the fate of the sludge. Now, let's ask Göran Persson here, which I believe has for a while had responsibility for this discussion during your time at the Environmental Protection Agency. So what do you think at that agency about the sludge and the sediments in dams?
Well, I can give some comments on the use of sludge from sewage treatment plants. And this is a problem in a way that in the sludge you find almost any chemicals that you use in the modern society. And to be able to use it in the long term for agricultural purposes, you have to remove most of these chemicals. But the idea we have in Sweden is really to reduce the emissions and the use of especially synthetic hydrocarbons and mostly the very persistent chemicals, to be able to use it in agriculture in the future.
Thank you, Göran. Let's ask if the Finnish panelists also would like to say something about this topic. Perhaps you can say something more about the sediments in all the dams around here.
Yes, around the Gulf of Finland we have been discussing the Leningrad Dam, of course. I just wonder if Oleg might have some comment on this.
First of all, I should say that we have the same problems with utilization of sediments from sewage treatment plants also. But I think that at least for the time being, we have no knowledge enough to try and to do something with sediments within the Neva Bay. And because it's still going in natural way. The dam itself have very little effect on sedimentation rates. But of course you should can be sure that these sediments contain very high amounts of toxic metals and chlorinated organics. But it's still a question of future suggestions.
Thanks.
Thank you, Finland. Of course, this is a very general problem because sediments occur in the entire Baltic Sea. And these sediments have a much higher concentration of toxic chemicals, heavy metals, and so on. So it's a general problem. And these sediments are not only resuspended because of weather conditions, but also, for example, trawling and other processes. Bengt-Ove, you might say something about the sediments and resuspension in general, not only in the dams.
Well, in a way, you could say that the total Baltic could be looked upon as a huge sediment trap, actually. There is certainly no shortage of sediment in the Baltic Sea, on the contrary. So you could say that as a huge ecosystem, the Baltic ecosystem is based on sediments. It's a kind of detritus-based sediment, which has a lot of effects which we might touch upon later.
Thank you very much. I think we'll continue with a question from the Swedish students who didn't have a chance to ask anything so far. Please.
Yes, my question is directed towards the Polish panel. Could you please tell us what you regard as being the worst environmental threat?
Thank you. You could comment this. Okay.
The question is so difficult that we don't know who has the duty to answer. I think that in our region where we are living, the most difficult problems are related with four main sources of pollution. The first and the most difficult is, as it was mentioned already, the toxins in sediments, especially the bottom of harbors. The second are the big two factories, one dealing with phosphoric fertilizers and sulfuric and all the products from sulfur. And the next is, of course, oil refinery. But I think that this question should be more specific, because if you are speaking about the danger, we have to indicate or just to ask if the problem is related to the health of the people, to ecological damage, or economy. And if we don't ask and we don't specify, it is very difficult to give the answer.
Thank you. Would you like to?
Maybe I try to explain, because the first number of our discussion according nutrients, and it is very serious problems in Baltic Sea. So I would like give you maybe some general information about loads which are flowing by rivers, because this is my main topic of my subject, and because man and nature are the cause of, maybe I show you, I don't know if this can to see, is about 7,700,000 tons of nitrogen per year, and it is from this value 65% is from non-point source and 33 is from point source. At present, technology enables to reduce municipal waste load about 50%. And we know that ministerial declaration concerning 50% reduction of nitrogen load would require to reduce the non-point pollutions. So we must concentrate for non-point pollution. This is a very difficult problem. And the similar calculation we can show for phosphorus. So, riverine discharge, the Baltic Sea receives 55,000 tons phosphorus from the land, and then 68% from point sources and 33 from non-point sources. At present, technology enables to reduce load from municipal and industry about 38%. So the rest, about 70%, should be reduced discharge from non-point sources. This is, like we know, a very unrealistic aim for us. And this indicates how difficult and different the ways are needed for this aim. Thank you.
Thank you. I think we should take the occasion here and ask the Polish panel. You see, last time we had a 2-hour discussion about eutrophication, so some of these facts that we just heard are, I think, known to many of the students. But one very strange thing about Poland is that Poland let much more of phosphorus to the Baltic Sea than nitrogen. This is different as compared to all the other countries around the Baltic Sea. Do you believe that this is true? If it's true, why then? Is it, are the measurements correct, so to speak, or is it that, for example, the nitrogen reduction in the Polish, from the Polish non-point sources are much more efficient than elsewhere?
Thank you. I'm sure that we can comment this, please.
I try. This is true. Of course, for us, it's an unpleasant situation like it. Even I know that from last year it was more level. It was 110,000 tons nitrogen per year and about 50,000 tons phosphorus per year. It was flowing from Poland into the Baltic Sea. But it was right level, of course.
Thank you. Thank you.
Thank you very much, Poland. I think we should let the Finnish students go on with the next questions, so we have more opportunities to question. Please, Finland.
Thank you again. So please, next question. About 6,000 students are waiting for it. Please.
Hello, I'm Janina Andersson from Turku. And I know this is a very enormous question, but I would like to know in what ways the composition of species has changed in the Baltic due to human activities.
Thank you. Well, that was, I think everybody here has an opinion on it. Perhaps we should start by Bengt-Ove Jansson, who is a marine ecologist and probably have a good survey of what has happened during the last 20 or 30 years. Bengt-Ove, please.
Well, we have discussed this problem a couple of times, of course, and we actually know no species in the original Baltic Sea which has become extinct yet because of man's use of fossil fuel, etc. you might find a displacement between different kinds of groups of organisms or specimens, especially from a functional point of view. For example, those animals who are living on settling particulate matter from the water column, what we call deposit feeders, they have increased. That's a typical sign of eutrophication, which increased the amount of particles in the water. And then in different parts of the coast, of course, you can see a switch in the fish community from in more or less sheltered areas. Those typical fishes who are common in a very clear water, like pike, perch, salmon, etc., who are very active, who have to run around large areas to collect food enough to survive. Two species who are more sluggish, who now, when the water becomes more turbid, don't have to swim around that much and waste energy of collecting. They more or less have just opened their mouths to get something to eat.
Thank you very much. I think we also should take the chance to ask Professor Marcin Pliński in Gdansk, because in his contribution last time he mentioned that 50% of the bottom fauna of the Gdansk Bay have disappeared since the beginning of the century. And do you still think this is true? And if this is true, what has disappeared, as the Finnish student asked?
Thank you. Please, Professor Pliński.
Thank you very much. I think that this problem is very important if you look on the eutrophication processes which held here in the Baltic Sea area as a whole, but especially here in the Gulf of Gdańsk. We observed for several years such huge, strange changes in the composition of the community of each of ecological fractions. It means in the phytoplankton, phytobenthos, in the zooplankton is not just clear if there are some changes in the species composition, but also in the zoobenthos and also in the fish communities. But I would like in the short time to stress that especially in the phytobenthos, as I said some weeks ago, we observed really, could say, two very important problems. One of this is the diminishing of the species, which we noticed in this fraction, that means in phytobenthos. And the second one is a diminishing of the area in which the phytobenthos species occurs. I think that's a very important problem if you compare it with the what's happened on the bottom with the suspended matter. It means that the organic matter which is sedimentated. Because in the beginning of the century, after the Lakowitz works, we know that the phytobenthos occurred till 25 meters depth. But now, recently, it means 3-4 years ago, we observed that this range is diminished only till 6 meters. As you see, there's a really very drastic change. And in my opinion, there are two causes which cause this effect. One of this is the increase of the organic matter which sedimentated on the bottom and changed the mechanical view of the bottom. It means before it was more sandy, rocky, and now it's a muddy bottom. This is very important because the plant should have something hard to touch. It means the hard substrate. But now does not exist. It means there's only some mud things. And the second one, the suspended matter, which is suspended in the water column, decrease the range of the penetration of the light, which is necessary for the photosynthesis. And there's the effect which we observed, the diminishing of the range of occurrence of the species of phytobenthos on the bottom. I think that's the first comment concerning this problem, but very, very important.
Okay, thank you, Marcin. I think the Finnish student was concerned about species that actually have been extinct. And we had a small discussion here in the Swedish panel, and we came to the conclusion that no species have been extinct, really. But of course, the relationship between different species and the space they have to live on has decreased in many cases, quite severely. That's true. I think we'll continue with one Swedish question now, just to turn it around a little differently. Please, a Swedish student.
Well, hello. My question is about the eutrophication and well, how is it about the acid rain? Does the acid rain increase the leakage of phosphorus in this catchment area? And in your case, by how much?
Will you please say your name also? Perhaps it's...
Well, my name is Paul Tigesen.
Thank you. Well, this is now a question about the connection between the various pollutants, the various environmental threats in the Baltic region. Does acidification connect to eutrophication? Is the situation such that increased acidification increase also the eutrophication? Who is prepared to answer that question? Perhaps we should go to the Finnish panelist and see what's happening there. Please, Finland.
Yes, thanks, Sam, for your comments. Maybe may I ask you, Paavo, to try?
Yes. At least there is one quite clear effect, maybe. The fisheries people can speak more about that. But those fish species which come up to the rivers from the Baltic Sea, they suffer from this acidification, salmonids and others. And that make some changes in the Baltic fish fauna. Maybe Carl Hilden can continue.
Yes, I think on the issue of causing eutrophication as such, I think that the acidification in the Baltic is a very minor component. It's at present, but certainly it has had effects on some of the fish stocks in the Baltic. But again, it's not mainly due to the airborne acidification, but rather due to the natural acidified clays which we have around the Baltic Sea, especially in the Gulf of Bothnia, and the agriculture activities on these clays which have caused acidification in the Baltic. So that is, for the Baltic Sea, perhaps the most important acidification problem at present.
Thank you very much. I think also in the Swedish panel we have a comment on this. Göran Persson, please.
Yes, I think the acid rain really affects in two ways. First, you have an increased leakage of substances like calcium, magnesium, and potassium. Because this is a problem when the forest soil when these substances are leached out of the forest soils. But the acid rain also affects, I think, the eutrophication in another way, and that is due to the fact of the increased deposition of nitrogen and nitrogen oxides. Because in many areas in the southern part of Sweden and in Denmark, the soil is saturated by nitrogen, and you get an increased leakage of nitrogen from these types of soils.
Thank you. So there is a contribution. Would you say that this is an important contribution to eutrophication?
I wouldn't say it is a dominating contribution, not at all, but perhaps the deposition of nitrogen oxides and also from ammonium directly on the surface of the water is more important.
Thank you. Well, there are many different relationships between the various pollutants, but let's go back to Poland now, and let's have a Polish student ask a question. Please, Poland.
I'm sure that many students would like to ask questions. Who is first, please? Yep.
My name is Monika Piotrowska. I am the student of University of Gdańsk and I study chemistry. And this is my question. In two Polish cities on the Baltic coast, namely in Szczecin and Gdańsk, there are phosphorus fertilizer plants. They both give rise to a lot of trouble for the environment. The plant in Gdańsk is one which causes most pollution, the Bay of Gdańsk, and large the surrounding areas. Do any such problems occur in your countries? How do you resolve the problem of phosphogypsum and other acidic wastes? Thank you.
Well, thank you very much. Who would like to ask that? Perhaps we should take a little turn here. And perhaps we should start by Estonia, Finland, because there are, in Estonia, I believe there is one of the most important sources for phosphorus in the entire world, actually. What do you say over in Turku, Åbo?
We do have a factory on the west coast of Finland, in fact, and it has caused quite a lot of eutrophication problems. The name of the city is Uusikaupunki. It's a long and complicated Finnish name, situated in the southeastern corner of the Botnian Bay. And there they have had quite practical and technical solutions, quite well functioning in time, but sometimes accidentally they have got very high amounts of phosphorus and other nutrients in the water area just off the factories. So we think it is a real environmental problem also in Finland.
What about Estonia? Do you have anybody from Estonia over there in Turku? And in such a case, do they have some comment on this?
Yes, we can only say that this problem is not. It is not a good answer for this problem in Estonia. We have many phosphogyps, but it is not produced any good products from this.
Thank you. I'll tell you that that was Professor Baltic Mikal from Tallinn Technical University. And, well, we would like to have in the future some good measurements on what's going on in Estonia, certainly. I don't think we have so much of that now as we would like to. So that's one of the weak points. We don't have good data for the previous Soviet Union countries. Now, let's go over and let one of the Finnish students again ask a question.
Thank you, Lars. We have to move to next item. May I ask some of our student guests to put next question, please?
Okay, my name is Christopher Boström. I study in Turku. My question concerns the salinity in the Baltic. In the first 3 sessions, the low quantity of salt in the Baltic Sea and the still lowering salt content has several times been presented as a negative feature. What for? Thank you.
Well, thank you. This is the eternal debate on the importance of the salinity of the Baltic Sea for its fauna and flora. Now, we do have several people here, marine biologists, that would be very able to answer such a question. Well, let's ask Bertil Hägerhäll if he can say something about that from his career as a marine biologist.
Well, you can see it at least as the number of species decrease. Being a marine botanist myself, I mean, I compare the Swedish west coast with the Baltic. On the west coast you have several hundred marine algal species, and in the Baltic maybe 20 to 30. And this is, of course, has a major influence on the whole ecology of the Baltic.
Mm. Thank you. Bengt-Ove, do you want to comment on this? Is it the people from north there feel a little discriminated because of the low salt.
Well, I'm very sorry for that.
Yeah.
But, well, it's the well-known fact that as both the fauna and the flora in the Baltic to a great extent consists of marine animals, and maybe most of the organisms once emerge in the sea. They have difficulties in standing low salinity. Their inner fluids have a fairly high concentration compared to the water in the northern Baltic, which means that a lot of fresh water tries to dilute these body fluids, and they have to put down a fair amount of energy just to continuously try to get rid of that fresh water. And not so many marine animals or plants can stand that, and that's why you have so few species in the Gulf of Bothnia.
Thank you. I think the Finnish panel also would like to comment on this, please.
Yes, there is one also very practical and obvious reason why a lower salinity is considered detrimental in the Baltic Sea. Of the three most important species of fish, cod is perhaps the most marine one, and the present very drastic decline, if you can get the camera on this picture of the cod stock, shows very clearly that this very drastic decline is largely due to decreasing salinity, and in connection with the decreasing oxygen levels in the deep waters. So certainly if the situation gets even worse, the cod will be in big trouble.
Thank you. Let's go over to a Swedish student question now, please.
Yeah, hello. My name is Steven von Stedink, and I have a question about these low levels of oxygen in the bottoms. Are there any methods that we can use to increase the levels of oxygen in the bottoms? In a way, an artificial respiration.
Thank you very much. You are talking about a huge project, I suppose, oxygenating the bottoms of the Baltic Sea. So it's really a great thing to do. Who would like to comment on that? Do we have a comment? Perhaps we should ask Göran Persson, who is in a way responsible for the Baltic Sea from the Swedish side, and Sweden has the largest coast to the Baltic Sea, in fact.
Well, no, it sounds really impossible to me, and I could imagine what amounts of energy that would require to try to pump oxygen down to the sediments. But I think there are other more qualified than me to answer this question.
Yes. For example, the Polish panel perhaps would like to comment on this. I know we have some people from technical universities. Do you have considered anything of the kind?
Please. I'm not from the technical university, but by the way, I would like to say, and I agree with our Swedish colleague, that it's very difficult to imagine to pump the oxygen to the bottom of the Baltic Sea. For example, the Baltic is like a lake, but for us it's a really very, very big sea. But in the lake, such technical equipment could imagine for the dash water, the water with enough content of oxygen. But till now, I think that's very difficult to imagine to construct such instrument for pumping the oxygen to the bottom.
Thank you very much, Marcin. I think Bengt-Ove Jansson also would like to comment on one of these old ideas.
Well,
Please,
I think we should remind ourselves that there is a very, very old idea that why don't we dig a little deeper in, for example, the Öresund, to let in more marine water which contains lots of oxygen. And it's an idea which is renewed every now and then, even today. To that you could say that it's not that sure that you would get a steady inflow of salt water with increased oxygen concentration, because as this saltier water is heavier, you will increase the stability of the Baltic water. So you will have even worse to hope that, say, the winds would make some kind of turnover from the surface water down to the bottom. So this is probably not a very good idea either.
Thank you. So we are stuck with the situation we have. The only thing is to reduce the oxygen consumption, I am afraid. Well, it's the Polish student who have the turn. Please.
Like to ask, please. Sorry, next time.
My name is Ewa Hauptmann-Mieszczuk. I am from the Technical University of Gdańsk. I have heard that Sweden promised to demolish all Swedish atomic power plants before the year 2010. I'm very interested in how this process runs nowadays. How many atomic power plants do yet exist in Sweden?
That's very evident that Gunnar Bengtsson is the man who should answer such a question. Please.
We have at present 12 power plants in Sweden, and there is a year-to-year review of the possibility of replacing them, and no firm decision and no final dates have been set except for the 2010.
Mm-hmm. What about the Baltic region? If we look at the Baltic region, the drainage area of the Baltic Sea, how many power plants do we have in the region?
Very near the coast, you have in Forsmark 3 plants, in Oskarshamn 3 plants, in Olkiluoto 2 plants, and Lovisa 2 plants, in Sosnovyj Bor near St. Petersburg 4 plants, and then the other plants are a bit further away from the Baltic coastline.
But they are still in the Baltic region. I mean, they are in the drainage area where the water flows into the sea, like in Galina, for example.
Yes, if you go to the entire drainage area, you would add, I guess, 1 or 2 dozen more power plants.
Oh, that much. So Sweden is a minor nuclear power country in the Baltic region, you mean?
If you include the very great drainage area, I would think so. Yes.
Thank you. It's time to turn to the Swedish students. Please. Some Swedish students have a question. Well, then the word goes on to Finland.
Thank you. We would like to make an additional comment to last question. We do have with us a guest from Lithuania, from Vytautas Magnus University, Dr. Glucininkas. Linas, could you please comment the situation in your country concerning atomic power?
Okay, I will try. In Lithuania, we have a big nuclear power plant in Ignalina. It has 2 reactors, every of which has power 1,500 megawatts. And this power plant was built on the blueprints of Chernobyl. So we have the same outdated reactors. The type of reactors, RBMK reactors. And one more information, that this plant was built on a geological fault. So we have a great problem in Lithuania with the nuclear power plant.
Thank you. Well, there is more wish to discuss nuclear power, perhaps. It's what about your opinion about the Ignalina power plant? Did you go there and see if it's safe according to our standards, or what you say?
I didn't go to Ignalina, but there is in general great concern in Western Europe about the Eastern reactors, and there is a big program going on of cooperation between East and West in order to evaluate the safety of the reactors. Generally, the experts are saying that the older types of Eastern reactors are so uncertain that many experts would like them shut down, whereas it is more up to discussion whether one could improve the safety of the more modern models of Eastern reactors. And a large program of evaluation is going on where many countries are involved, including Sweden and Finland.
Mm-hmm. I know that earlier there was plans to enlarge the Ignalina power plant. Has those plans stayed after independence, or what do the Lithuanians say? Let's go over to Turku, where we have the Lithuanians.
So, could you take over and comment this question?
Yes. We have our plant with the 2 reactors, but it works not on the highest level at this time.
Thank you very much. Now it's time for the Swedish students to come in, it looks like. The Finnish have to wait a little. So the Swedish, please.
My name is Thomas Bergström, and I'm a student here in Uppsala University. I have a question also about radioactivity. I wonder if there are any historical record of releasing radioactive material or actual dumping. And the following question is, of course, have we seen any effects of those?
Well, again, I suppose, Gunnar, you would be the person to start the answer of that question.
There is, within the framework of the Helsinki Commission, there is a large program for evaluating the contents of radioactive materials in the Baltic. And this program is not at all finished, but it is very active with participation, I think, from 7 countries. And one will find out from this program what the total effect on the Baltic of the various releases has been. But very generally, the main contributions to the present contents of radioactive materials in the Baltic are the fallout from nuclear weapons tests and the fallout from the Chernobyl accident. Next in magnitude come contributions which are pouring in through the Danish Straits, and only third are contributions from releases from the neighboring nuclear power plants.
What about Estonia again? I know that there are quite an amount of radioactivity in the oil shell of northern Estonia, and some of that has been mined, and I guess there is also a release of radioactivity. Has that been monitored? Let's go back to Turku, where they have the assembly of experts from the region. Please, Turku.
And Professor Mika from Tallinn Technical University, please.
Yes, there is estimated a little radioactivity, not in oil shale, but in so-called Dictyonema shale. That's on part of the